Here's an example of a homework problem where you're asked to use the half-angle formula to find a value of cosine, in this case, for a half angle. So we're given that cosine of alpha is equal to 3/4, and asked to find the exact value of cosine of alpha over 2. In this problem, you're definitely going to need the half-angle formula for cosine, which says that cosine of a over 2 is equal to either positive or negative square root of 1 plus cosine of a, cosine of a, all divided by 2. Now, it's important to note that this isn't saying that cosine of a over 2 is equal to both positive and negative square root of this. It's up to you to choose the correct sign depending on the value of a, and depending on what quadrant this angle lies in, really. So that's where this extra bit of information, the fact that pi over 2 is less than alpha, which is less than pi. So I set this up with, this is really saying that alpha is in quadrant 2. Draw a little picture here. Here's pi over 2. Here's pi radians. So if alpha is between pi over 2 and pi radians, then it's in quadrant 2. Now, I want to know what that means about cosine of alpha over 2, so I want to divide everything by 2. Which, by the way, so dividing by 2, that's the same as multiplying by 1/2. I could write this on the left side here as, so I'm dividing by 2 over 1, so I could write it as pi over 2 times 1/2 is less than alpha over 2, which is less than pi over 2. So alpha over 2 is between pi over 4 and pi over 2, which means that alpha over 2 is it's between pi over 4 and pi over 2. It's somewhere in this wedge here for alpha over 2. So I know in this case that cosine of alpha over 2 is going to be positive. In quadrant 1, all of the trig functions are positive. Okay, so using that formula, and let me slide this up a bit. Oops. Cosine of alpha over 2 is equal to, so we've decided positive root of 1 plus cosine of alpha, which was given. That was 3/4. That was given in the problem. Cosine of alpha is 3/4 right there. Okay. So there's different ways to approach simplifying this. I guess one thing we could do is go ahead and add the terms in the numerator. So we could think of that 1 as 4 over 4 plus 3 over 4. So we have the square root of 7/4 divided by 2. And again, we could look at that 2 in the denominator as 2 over 1. Instead of dividing, multiply by the reciprocal. So this is times 1 over 2. So this is equal to the square root of 7 over 8. Okay, so this could be simplified. And here's where I don't know, actually I am in front of the computer. Okay, I just paused to check the instructions in my math lab. And in your homework, you are asked to rationalize the denominator and to simplify your radicals. I do appreciate when students simplify their radicals. It's not important to me that you rationalize your denominator. So let me start out by doing what I would hope that all students would do. So this is equal to the square root of 7 over the square root of 8. Now the square root of 7 is a prime number, that can't be simplified. But the square root of 8, let me write down here, is 4 times 2. There is a perfect square that's a factor of 8. And so you should go ahead and take the square root of any perfect squares. So the square root of 4 is 2. But this second 2 here, this is prime, that needs to stay under the radical. So the square root of 8 is equal to 2 square root of 2 over the square root of 7. So on an exam, you are fine leaving it like that. my math lab wants you to rationalize denominators, so I can do that by multiplying numerator and denominator by the square root of 2. I need to rationalize this radical right there. And so square root of 7 times square root of 2, this is square root of 14 in the numerator. In the denominator, I have 2 times, the square root of 2 times itself, that's 2. So I have 2 times 2 in the denominator, which is 4. And so my final answer is positive square root of 14 over 4.